So Chapter 8, you're doing basically the same thing you were doing in Chapter 6. If you recall, in Chapter 6, you were looking at a single observation. You were determining where that single observation fell on a curve, and you were measuring the likelihood or probability of somebody shorter than you or taller than you. This time, in Chapter 8, we're going to look at not a single observation, but a sample. A sample gives us more evidence. For example, I'm going to kind of pretend I have a product, because this is what you're going to end up doing in your final project. I have chips. I measured bags of chips, and the manufacturer says that they should weigh 28 grams. Notice I'm using mu. That's a population should weigh 28 grams. My sample, however, of 20 bags weigh 28.3. I'm trying to test, is mu greater than 28? So my mu for my null is mu equals 28. So this is my null, this is my alternative. So I'm trying to check, yes, this number is larger than 28. And I'm looking at 20 bags. Now the difference with Chapter 8, Chapter 6, you would have had this same information. It would have been 28 grams. Your x, your single value, would have been 28.3, and my n would have been 1, because I'm only looking at one bag. So if I take one bag of chips and it's 28.3, that's not a lot of evidence to say overall most of these bags have more chips. So what you did in Chapter 6 was you found the z-score, and the z-score is the position on this normal curve where this is 28. So 28.3 is truly more weight than 28 itself, but let's see as a probability if I select one bag that would happen. So you said 28.3 minus 28 gives you a distance of 0.3. It's positive because it's higher. And then you had to divide by the standard deviation. So I'm going to make my standard deviation, notice it's S, because it is of the sample, of, let's just go 0.5. So I take my calculator and I take 0.3, and I'm going to divide it. So I'll show you what I'm doing here. 0.3 divided by 0.5, and I found my z-score equal to 0.6. So it's not an entire whole step above. I would look up 0.6 in my table, and I would get a probability that reads this direction, and a probability from, take that minus 1, and I would get 0.27. So the chance of that happening is 27%. Fairly likely that I would get a bag that weighed 28.3. Yes, it is more, but really not significant amount more. Notice that word significant. In Chapter 8, essentially what you're doing is, again, saying the manufacturer says they should weigh 28 grams. I took a sample of 20 bags, much more evidence than a single bag, and they all together weighed 28.3. So I'm using the same standard deviation. Okay, and so again, I'm looking where I'm landing on this curve. So here was 0.6 steps above. That was my z-score. So now I'm trying to figure out, with this sample, it's more evidence suggesting that they weigh more than 28, but still, is it significant? Is it quite a bit more? So my z-score is my sample weight minus the weight of the mean divided by the standard deviation. So this is all the same, but now the size of my sample has to come into play. I have to do the square root of 20. So again, I would get 0.3. I would take my calculator, 0.5 divided by the square root of 20, and that gives me 0.111, and now I'm going to divide those two numbers. So I do it in steps. Kind of helps me with the order of operations, and I get z equals 2.7. So now on the curve, here's 28, but now I'm 2.7 steps above, so I'm up here. So this suggested more evidence when my average, my mean of 20 samples, was weighing more versus just one sample. Much more evidence. So my z-score has to change in relation to the number that I'm looking at. Up here I looked at 1, and if you wanted to, you're really doing the same formula because the square root of 1 is 1. Okay, not much evidence with 1, but lots of evidence with 20 that they are weighing more. In fact, when I look up that 2.7 z-score, I get approximately 0.0036 on this side. So remember, I've subtracted it from 1. My table reads to the greater than, my table reads to the less than, and I subtract from 1 to get to the greater than. So essentially the same operations, but you just have to look at, I'm only looking at 1 versus I'm looking at a sample. A sample gives you much more evidence.